Modern refrigeration. Chapter 21, heat exchangers. Just a little information. This is 63 slides. It's not that long in time, but it's a lot of information. You should have your book out and going through these pages because a lot of the pictures you will need to look at them in the book. They're not very clear sometimes on your phone or on a computer. So get your book out. The objectives. We're going to compare and contrast air-cooled and liquid-cooled. We're going to explain the construction of fin tube, plate, and microchannel evaporators. Compare and contrast domestic and air conditioning and commercial refrigeration evaporators. Summarize the operation of evaporator defrost controls and defrost methods. Describe the different types of water-cooled condensers. Explain the modes of operation of evaporative condensers. Compare and contrast domestic air conditioning and commercial refrigeration condensers. Describe the construction of different types of air-cooled condensers. Explain the methods of head pressure control that uses condensed air louvers, fan speed, and cycling, and electric heat. Summarize the operations and purpose of suction line, heat exchangers, and commercial liquid line subcoolers. Explain the construction and operation of plate heat exchangers and heat recovery systems. Evaporators. Cool a circulated medium, evaporate liquid refrigerant, superheat vapor refrigerant. Basic types are air-cooled and liquid-cooled. Air cooling evaporator categories. Low temperature applications, -10 to 28. That's usually a freezer. Medium temperature applications, 28 to 40. Now that could freeze, but normally these are used to 28 degrees for a beer cooler, something with alcohol in it. May use air defrosting. High temperature applications, 40 degrees to 60 degrees. Frost does not normally form. Humidity kept between 75 and 85%. This is usually for like produce. You don't want it too cold, but you also don't want frost to form on it. Air cooling evaporator circulation. Natural draft, gravitational circulation, or convection, something that the air just normally passes through the room. Warm air goes up and it heads towards the cooler, and up and down it goes through the room. Forced draft evaporators. Fans blow air over evaporative coil. Various designs and builds different applications. Liquid cooling evaporators, designed to cool a liquid rather than air. Two primary build types are tube within a tube and immersed. Two types of immersed evaporators are brine and sweet water. Immersed evaporators, brine solution. Evaporators immersed in a brine solution. Brine is a mixture of water and an added substance. Brine can cool below 32 degrees without freezing. Functions of brine solution: raise the temperature at which water will boil. Lower temperature at water will freeze. Sometimes brine solution is used for de-icing because it can hit a colder temperature like 20 degrees and still not freeze to it. Immersed evaporator, sweet water. Evaporators immersed in sweet water, tap water, allows the freezer to freeze around the evaporator during the on cycle and melt during the off cycle. They're usually used in like soda machines. Fin tube evaporators. This is the most widely used, almost, I would say, probably more than 80% of them are fin tubes. Use these in your home air conditioning, commercial air conditioning, walk-in coolers, walk-in freezers. All use normally a copper or aluminum coil with aluminum fins. That increases the amount of air or the amount of cold exposed to the air and will absorb the heat of that air. Fin arrangements. Various methods of bonding to tube. Spacing determines how many fins can be used. More fins means more cooling capacity. Space may be wider to prevent icing over. Again, the fin arrangements is so important. If the fins are too close together, it will cool better, but it also will stop airflow from going through. It's taking too much space, so you might need a larger coil. A wider will prevent icing over. More air moving through will be less chance that the coil will freeze. Plate evaporators. Each plate is made of 2 metal sheets that are welded together with a passageway going through the 2, crimped to a shape. It can be used for forced draft or natural draft. Microchannel evaporators. This is the new thing in home air conditioning. Most compact and efficient build. Tightly packed fins arranged surrounding a small refrigerant passage. Large amount of surface area in contact with the air, usually made of aluminum. We do have a coil like this in our lab. Domestic appliance evaporators. Natural draft. Do not need a fan, but there's a risk of tubing being punctured and leaks. I have a stand-up freezer at my home that the shelves are actually the coils and fins. So I set frozen products sitting right on the coils. That's why there's that risk. Forced draft requires a fan, keeps evaporator out of sight and risk of puncture, must have automatic defrosting. Air conditioning evaporators, forced draft, installed in or above an air handler cabinet, mostly fin tube. Many are A coils, distributor direct refrigerant parallel circuits, more in uniform temperature across the coil. Just to let you know, that is not an A coil in the picture, it's an actual N coil. The first M coils and M coils, N and M coils I've ever seen were ream units. Commercial refrigeration evaporators vary by system, capacity needs, and size consideration. They're usually very small and thin, so they can be in the middle of the room where you have to walk underneath them. Mostly forced draft, which means they have fans built into the bottom of them. Defrost often needed, so it gets defrosted, I would say, probably every 20 minutes to every 45 minutes. Higher heat load capacity than other domestic appliances. And what this means is you could take air that is 80 degrees, put it through those coils, and in a matter of 30 minutes, that walk-in cooler is going to be at temperature because it moves a lot of air. Commercial refrigeration evaporator location. This is a ice box, maybe a meat cooler. And again, on things like this, the picture's better in your book. Evaporator defrost controls. Defrosting prevents blocked airflow. Defrost timer. Device that starts and stops defrost cycle. Variables used to control defrost timer operation. Time, temperature, and pressure. This is a standard unit. It just depends on what it controls. It either controls a reverse flow of refrigerant, electric coils, or no heat at all, just air temperature to defrost the system. Time initiated and time terminated defrost turns on defrost operation at preset time, ends defrost operation at preset time. So this doesn't use any temperature controls. This is just turns on every 30 minutes for 10 minutes, and that's all it does all day long. Uses only when length of time needed remains constant danger of over defrosting. What that means is there's a point where you get that coil so warm that it takes much more time for it to start freezing again, or you can defrost the room by leaving it on too long. Temperature terminated and pressure terminated defrost timers. A temperature terminated defrost timer has a little bit of a temperature probe sitting on the lower part of the coil, which would defrost last. And as that temperature drops on that or rises on that one spot above freezing, maybe 35, 36, 38 degrees, it will shut the system out of defrost and go back to cooling mode. The pressure terminated is it knows when the pressures get to a certain peak. And remember, the colder the refrigerant, the lower the pressures. The higher the pressure, the higher the temperatures. So it uses the temperature of the refrigerant to determine whether or not the system has been defrosted or not.